You drift toward the edge of reason, where particles slip through barriers like dreams through silence. This is the story of the universe's quietest rebellion, a tale of possibility beyond impossibility, of matter dancing through walls. Tonight, you'll float into the heart of uncertainty and find comfort in the strangeness of it all. You lie still, your body easing into the quiet rhythm of the night. The world outside fades. The hum of your thoughts softens, like water becoming mist. Here, in the hush between breaths, a quieter world waits, not far away, but deep beneath everything you see. You begin not with stars, nor atoms, but with the spaces between. Between each grain of sand, between each beat of your heart, between the tiniest parts of matter, there is emptiness. Or so it seems. But the truth is more delicate, more curious. Space, even the smallest corner, is not truly empty. It hums, gently, invisibly. It's like the silence in a concert hall before the music begins. Silent, yes, but expectant, charged with possibility. Your mind floats there now, drifting into this stillness. You imagine the tiniest scale imaginable, far smaller than a cell, smaller even than the parts that make up atoms, down where electrons swirl like whispers, and protons stand quietly in the center, holding their ground. Even deeper than that, into the gaps between particles, into the supposed nothing. What do you find? Not stillness, but trembling. Not emptiness, but potential. This is the quantum field, the strange stage upon which all particles play. And here stillness isn't a lack of motion, it's a balance of every possible motion, humming softly in place. Like a coin spinning so fast it seems still, even as it dances on its edge. The space between things is filled with this hum, fluctuations, like ripples that never quite become waves. Particles flicker in and out of existence for the briefest flashes of time, like fireflies blinking in fog. They appear, disappear, and sometimes leave behind a mark, a ripple, a memory in the fabric of space itself. This flickering, this gentle unrest is the sea from which all matter rises. And yet, it is so gentle, so constant, that we call it stillness. It is the kind of movement that comforts, not startles, a lullaby, not a storm. You might imagine atoms as tiny solar systems, with electrons orbiting a dense core. But this picture is too still, too neat. In truth, electrons are not tiny marbles circling in tidy paths. They are clouds of possibility, smears of maybe, floating in uncertainty. You can't say exactly where one is, only where it's likely to be. So even inside an atom, the smallest piece of matter you can touch, there is space, and within that space, uncertainty, and within that uncertainty, movement, soft, ghost-like. Never fully seen that your mind follows one of these electrons, just for a moment. It does not sit in place. It does not follow a circle like a planet might. It exists in a haze, like a thought before it is spoken. And this haze, this uncertainty, is not a flaw. It is nature's way. This is what quantum physics teaches you, not to expect certainty, but to expect possibility. And that begins in the spaces between. You feel the air around you now, still, soft, but somewhere in that stillness, particles flicker and vanish and appear again endlessly. Even here, in your room, in the space between your fingers, in the breath before your next, the rules of reality are gently bending and flexing. There is comfort in that, because if even the quietest space is never truly empty, then perhaps you are never truly alone. If even the smallest gaps are filled with movement and chance, then the world is more connected than it seems. You might wonder why any of this matters. What good is a particle flickering into existence for a fraction of a second? But from these flickers, from this soft chaos, arises everything. Stars are born, light shines, atoms hold together. The stillness between things is not just the backdrop, it is the beginning. So tonight, as you drift closer to sleep, you rest not on a bed of stillness, but on an ocean of gentle uncertainty. Your body is made of atoms, and those atoms are mostly space. But that space is not nothing. It is everything, waiting to become something. And that, in its own quiet way, is beautiful. Even your thoughts, slow and sleepy now, float like particles in a field of possibility. They rise and fall, appear and fade, always dancing, always soft. There is a term for the kind of quiet that fills the universe at this level. It's called the vacuum state, but it's far from empty. It is a field of minimum energy, of lowest vibration, of stillness so profound it shimmers. And from that field, sometimes, particles are born, not with force, but with grace, like ideas in the dark, like dreams you didn't expect. And so we begin, not with sound, but silence, not with action, but readiness, not with certainty, but with the soft weight of what might be. This is the stillness between things, the space where every possibility is cradled before it is chosen, the canvas before the stroke, the pause before the note, the breath before the voice. Let your mind rest here a while longer, in the gaps that aren't empty, in the quiet that hums, in the stillness that is never still. And now, with your body loose and heavy, with your thoughts like drifting leaves on a glassy pond, you might begin to wonder, if even the smallest boundaries aren't quite solid, what is a wall, really, and what might wait on the other side? Close your eyes, let your breath ease out, slow and deep. You are floating now, not in air or water, but in the soft fabric of the unseen. You've left behind the noise of daily thought. What lies ahead is a world of boundaries, not walls. You can touch, but thresholds you can feel. In your everyday world, a boundary is something solid, a wall, a fence, a closed door. It divides here from there, inside from outside. But in the quantum world, boundaries are more like suggestions, less like brick, more like breeze. Imagine a single particle, let's say an electron. It drifts through space, not like a marble, but like a mist. It isn't in one place, not exactly. It has a tendency to be in certain places, a preference, a leaning, but never a promise. Now, picture this electron moving toward a barrier, not a physical wall, but a region of higher energy. Think of it like a hill made of resistance. In the classical world, if the particle doesn't have enough energy to climb the hill, it stops. But in the quantum world, something strange happens. The particle hesitates. It hovers near the barrier, like a child staring at a locked gate. It should bounce off, retreat, give up. But instead, it softly spreads, like fog curling around a tree. Its presence leaks into the forbidden space, even though it has no right to be there. This is the dreamy boundary, not a stop sign, but a soft border. Not a hard no, but a whispered maybe. And in that maybe, the rules begin to bend. Might think of it like a shadow stretching beyond its object. The electron's probability seeps into the place it shouldn't reach. Its wave function, that soft math cloud that tells us where it might be, doesn't end at the wall. It continues, just thinner, fainter, more unlikely. But still there, pause. Hear and breathe. Let your mind rest on the image of a barrier that allows a particle to almost pass through. Not because of strength, but because of possibility. Sometimes the electron does more than stretch. Sometimes it appears on the other side, not having jumped over, not having broken through, but having tunneled, as if the wall were a curtain and it slipped through a thread in the weave. But that's a story for another night. Tonight, we stay here at the boundary itself, this strange in-between place where the rules you know begin to soften. In the language of physics, we say the particle faces a potential barrier. But that word potential is important. It doesn't mean actual, it means possible. The wall exists, yes, but not like a brick exists. It exists as a region where energy rises, where the particle shouldn't go. But might your body understands boundaries, your skin, your breath, your heartbeat. But deep inside, at the quantum level, your own particles ignore the rules of up and down, of in and out. They move to rhythms older than light, following probabilities instead of paths. Think of raindrops on glass. Some stop, some slide, some hang in place, almost suspended. Now imagine if one drop, against all reason, passed through the glass without breaking it, quietly, completely, as if the boundary were only a story the glass told itself. This is the mystery we stand beside tonight. The dreamy edge where matter and energy meet resistance. And do not stop, they simply stretch. In this world, particles don't ask, can I go through? They ask, what are the odds I might appear on the other side? It's not a yes or no. It's a maybe wrapped in a maybe wrapped in a mist of chance. And here's something even softer to hold. The thinner the barrier, or the lighter the particle, the higher the chance it might tunnel through. So even the smallest change, a narrowing wall, a softer particle, can shift the story. Boundaries begin to feel more like invitations than commands, less like locks, more like veils. Now imagine that you are the particle, not made of one, but made of many. And each part of you, each electron, each proton, moves with this quiet courage. It approaches the impossible and doesn't stop. It stretches, it shimmers, it tries, not with defiance, but with grace. This is what the quantum world offers you, not certainty, but beauty in the almost, in the moment before the fall, in the whisper before the step. You're beginning to feel it now. How resistance doesn't always mean denial. How barriers can be both strong and soft. How something can be both unlikely and real. Even the atoms in your pillow, the electrons in your bones, are living out this paradox. Every moment they flirt with boundaries. Every moment they hum with chance. You let go of the need to draw lines. You let go of the need to know exactly where a thing is, or isn't, because here, in this twilight space between solid and soft, truth is a matter of maybe. There's a lesson in that, not just for science, but for living, that some walls we meet are not to be broken or scaled, but to be softened by patience, that some boundaries are made of thought, and thought can change. Now, breathe again, slower this time. You're lying in a world that is more fluid than it seems. A world where even particles are unsure of their place, but still they move forward. And you're not so different. You face things that seem immovable, and yet something in you stretches. Something in you hopes. You drift now at the edge of the boundary. You trace its surface, not with hands, but with curiosity, and you begin to wonder if a particle can reach the other side without force or sound. What else might pass through the impossible? You rest now, deeper than before. Your thoughts are lighter, like leaves on a pond. In this calm, your mind reaches gently across the strange landscape of the quantum world, a place where even the impossible waits to be explored. Last night, you hovered near a boundary, a hill too steep, a wall too tall, a region too forbidden. But in this chapter, something changes. The particle, quiet, soft, insistent, doesn't stop. It vanishes, and then it reappears, not on top of the wall, not broken through it, but beyond it, as if it had never been blocked at all. This is quantum tunneling. A particle, faced with an impassable barrier, sometimes simply appears on the other side, without climbing, without breaking, without following a path you can see. It's not magic, though it feels like it. It is math. It is probability. It is real. You imagine it now. A gentle electron, too weak to pass through a barrier by classical rules. It reaches the wall, its wave function trembling, stretching. It shouldn't pass, but it does. Not always, not often, but enough to light the sun, enough to power your phone, enough to shape reality in quiet, essential ways. The wave function, that soft cloud of possibility, doesn't stop at the wall. It fades, yes, thins out. But if the wall is narrow enough, or the particle small enough, the wave function extends all the way to the other side. And what does that mean? It means the particle has a chance to be found there, not by force, not by choice, but by the shimmering dance of probability. You might think of a ghost walking through a wall, but it's gentler than that. It's more like a whisper slipping under a door, like light bending where it shouldn't, like fog curling through a crack you didn't know was there. You feel your breath slow. You are the observer now, watching the improbable unfold with soft wonder, and the truth begins to settle. Particles do not move the way you expect. They flicker, they fade, they reappear. Tunneling is not about going through a wall. It's about never needing to dot. It's about the particle existing on both sides of the boundary, but only being found on one. When you look, it's about potential becoming presence, not by force, but by chance. In classical physics, you need energy to climb the hill, but quantum physics allows a shortcut, a secret passageway carved, not by effort, but by the sheer strangeness of uncertainty. The electron doesn't break rules. It simply lives in a world where the rules are softer than they seem. And these shortcuts, these tunnels happen constantly. They are not rare miracles. They are steady whispers in the fabric of everything. In the heart of a star, for example, hydrogen atoms must come together, but they repel each other like two magnets turned the wrong way. They don't have the energy to collide. Yet, in the heat and pressure of the sun, tunneling gives them a secret door. They pass through the barrier of their mutual repulsion. And when they do, they fuse. And when they fuse, they release light. The light that reaches your skin, your eyes, your dreams. So tunneling is not just a curiosity. It's the reason dawn exists. It's the silent shortcut that fuels the stars. Pause here, let that rest inside you. A tiny, forbidden crossing, repeated again and again, creates warmth, fire, and life. Tunneling happens inside your body too, in enzymes that move electrons, in reactions too subtle to see. Your own cells rely on pathways no classical law can explain. And in the machines you use, the ones that light up, compute, connect, tiny particles tunnel through barriers in microchips. They move where they shouldn't, and that motion, improbably allowed, becomes the flow of electricity, becomes function, becomes reality. The world you know rests on quiet impossibilities. You drift with that thought, held in a hammock made of wonder and reason. Each swing takes you deeper. There is something comforting in this, that even when blocked, there may be another way, not through strength, not through will, but through patience, through softness, through the shimmer of what might be. You are not a particle, but you too have faced walls. You felt stuck, too small, too far, and yet there have been times when you found yourself on the other side, not knowing how, only knowing you had arrived. This is tunneling in the human sense, not just a theory, but a metaphor, a reminder that what seems impassable may not be final. That possibility always has a thread. However thin, you return now to the particle still small, still humble, still glowing with quiet courage. It begins on one side of a barrier. It is not supposed to cross. But when you look, when you measure, it's there, waiting where it shouldn't be. This is not a trick. It's a truth, born from the mathematics of quantum theory, born from a world where presence is a question, not a location. Tunneling does not explain why a particle appears. It explains how it can, and that may be enough. You may be wondering now, is it random? Yes, but not without rules. It follows a probability curve, steeper barriers, thicker walls, lower odds. But always there is a chance. Always there is the shimmer. You breathe in, you feel your own particles, the ones that make your blood, your bones. You picture them moving, stretching, flickering. You imagine them tunneling, quietly rewriting the map of where they're allowed to be. It's humbling and beautiful. This secret shortcut is not paved. It leaves no footprints. It leaves no trail. It is a passing through, a ripple, a fade, a reappearance. You don't feel it. You don't hear it. But without it, the world would freeze. Without it, the stars would go dark. Without it, nothing would grow. Tunneling is how the universe whispers. I know it's unlikely, but try. You rest your thoughts there, on that sentence, on that truth. The laws of physics, it seems, are not just strict and solid. They are tender. They leave room for the improbable. They make space for mystery. You drift now, not forward, but inward, into that possibility, into that softness. And as you float, as you dim, you begin to wonder if uncertainty allows for shortcuts. What else might it allow? You breathe in, slowly, deeply, letting the weight of certainty slip from your chest. The world around you softens, edges blur. What was fixed becomes fluid. You lie still, but your thoughts begin to move like mist across a quiet field. In the world of quantum physics, there is a truth both tender and strange, a truth whispered by a man named Werner Heisenberg. He didn't shout it, he didn't carve it into stone. He simply noticed that when you look too closely, the world slips out of your grasp. It's called the uncertainty principle. It tells us that, at the smallest scales of nature, there are pairs of things you cannot fully know at the same time. One always blurs the other. The more clearly you see one, the more softly the other fades. Position and momentum, where something is, and how fast it moves. You might imagine watching a dancer. If you fix your gaze on her feet, marking every step, each landing, you lose track of her flow, her spin, her speed. But if you focus on her motion, you can no longer say exactly where she is. Not precisely, not at once. This is how particles move, like dancers unseen, like songs you remember only in pieces. The more you know where an electron is, the less you know where it's going. And if you focus on its momentum, how it pushes, how it flows, you lose sight of where it is now. But this isn't a mistake. In your tools, it's not an error of the eye. It is the way the world works, fundamentally, delicately. Heisenberg didn't say that everything is unknowable. He said that knowledge comes with limits, not because you aren't clever enough, but because the universe is drawn in soft lines. Particles are not tiny billiard balls, zipping predictably through space. They are waves of potential, rippling, in patterns of maybe, of sometimes, of both here dash and dash not dash here dot. You rest inside this idea, not with frustration, but with wonder. Because what if uncertainty isn't failure? What if it's freedom? What if the lack of precision is not a flaw in nature, but an invitation to pause, to observe, to accept not knowing as a kind of knowledge? In the language of physics, the uncertainty principle is simple. The product of the uncertainties in position and momentum can never be smaller than a tiny, sacred constant. Planck's constant, carved into the laws of reality. But tonight, there's no need to carry the numbers. You only need to carry the feeling that to see clearly, you must let go of complete clarity. You turn inward now. Imagine your own particles, millions, billions, shimmering in your body, each one uncertain, each one moving, not with absolute purpose, but with a kind of graceful ambiguity. Your atoms do not need exact paths. They only need possibilities, and yet they make you, they hold you, they carry the pattern of your life, woven from this soft uncertainty. The world, at its smallest level, breathes in chance. This doesn't mean chaos. It doesn't mean disorder. It means rhythm. It means balance, like wind in a field, like tides in the dark, like dreams you remember not as facts, but as feelings. And it isn't only position and momentum. There are other pairs, energy and time, spin and orientation, questions that cannot all be answered at once. The universe guards its privacy gently, and you do too. There are parts of you cannot observe while moving through them. Emotions you cannot pin down while they are blooming. Choices you understand only after they've passed. You know this. You've lived this. Heisenberg's principle is not just about electrons. It is about existence. To be is to blur. To live is to shimmer. Let that soothe you. You don't have to be completely certain tonight. You don't have to measure every thought, every breath, every step. It's enough to move through the softness. It's enough to accept not knowing as a kind of grace. Particles, after all, are not choosing to hide. They are simply behaving as they must, spreading out across possibility, becoming presence only when observed. It's a beautiful idea. The world does not collapse into a single state until you gently look. So what you see depends, always, on how you look. Observation matters. Attention shapes reality. This isn't poetry. It's physics, and you can feel it now. The strange and tender truth that what is seen is changed by the seeing. You've felt this in life, too. The way a child stands taller when watched with love. The way silence deepens when listened to with care. The way a moment sharpens under attention. You rest in this truth, that your awareness is not passive. It is creative. It participates. It matters. So tonight, let go of the need to grasp everything tightly. Let your mind loosen its grip. Let your thoughts ripple like waves, interfering, fading. REAPPEARING. Your breath is part of this rhythm. Inhale, exhale, not fixed, but flowing. Even your memories, where they are stored, how they return, are touched by the rules of uncertainty. The mind is not a vault, it is a sea dot, and the sea does not keep still. You drift with that image now, floating in a world where not every question has one answer, where not every line is straight, where the smallest things defy precision because they are too rich, too full of motion to be caught all at once. This isn't a flaw, it is the softness that makes life soft. As you sink deeper into sleep, you begin to feel the wisdom of uncertainty. Not everything must be defined, not everything must be held. Some truths are best felt in the blur, and as your breathing slows, as your body rests, in the shimmer, you might begin to wonder, if we cannot know everything about a particle at once, what does it mean to know it all? You feel a warmth now, not heat on the skin, but something older, a memory of warmth, a golden light behind your eyelids, soft as the hush before morning. The sun has always been there, a quiet presence, rising without question, painting your days and guiding your sleep. But tonight you journey deeper, not to its surface, but to its secret. Inside the heart of the sun, something impossible is happening. Not once, not sometimes, but constantly, tirelessly. A reaction that defies classical physics. That shouldn't work, but does. It begins with hydrogen, simple, pure, the lightest element. Each atom holds one proton, a tiny positive charge, floating alone in space. In the sun's core, billions of these protons crowd together. They swirl in plasma, a sea of charged particles, so hot it forgets what it means to be solid, liquid, or gas. Temperatures reach over 15 million degrees Celsius. A pressure beyond imagining squeezes inward from the weight of the sun's own gravity. And yet, even in this fire, something strange is needed to keep the light alive. Because protons repel, both carry the same positive charge. Like to north poles of a magnet, they push away. Get close enough, and the force between them stiffens, refuses, rejects. Classical physics tells us they should never meet. No matter the temperature, no matter the pressure, but they do. They meet, they fuse, they become something new, a helium nucleus, and in the process, they release light, they release energy, they release you in a way because everything you are is built on that light. The mystery is this: how do they overcome the wall of repulsion? They don't, they tunnel. You picture it now, two protons drifting closer, hesitating, like dancers unsure of their step. They feel the barrier rise, the electric force pushing them apart. But the quantum world doesn't wait for permission. Instead, the proton's wave functions stretch, not with force, but with possibility. They reach across the barrier, through the forbidden space, and sometimes just enough, they appear on the other side. This is quantum tunneling. At the scale of stars, without it, fusion would fail. Without it, the sun would dim. Without it, the sky would be dark. The energy you feel on your skin during the day, the warmth that grows the trees, that stirs the winds, is born in those silent crossings. It's the result of countless protons passing through the impossible, not by climbing, not by burning, but by softly disappearing from one side of the barrier and reappearing on the other. This should comfort you, because even the greatest light in our sky relies not on brute strength, but on probability, on softness, on a chance that repeats itself millions of times each second. Let your breath move like sunlight now, smooth, rhythmic. Draw it in, and feel the chain of reactions that made it possible. Proton meets proton, tunnels, fuses, releases. Energy in the form of gamma rays. That energy begins a long journey, bouncing, scattering, colliding inside the sun for thousands of years. Eventually, it reaches the surface. And from there, in just over 8 minutes, it travels across space and touches your skin. So the warmth you feel from the sun today was born in its heart, long before you were born. It tunneled through barriers, through time, through space, and here it is, lighting your face, warming your pillow, cradling your dreams. The scale is hard to grasp. Each second, the sun converts 600 million tons of hydrogen into 596 million tons of helium. The missing 4 million tons, transformed into energy, into photons, into heat, into light. But it starts so small, with a single pair of protons, with a tunnel no one sees, with a flicker of chance made real. You may wonder, why does tunneling happen at all? Because in the quantum world, particles are not points. They are waves, spread out patterns of possibility. These waves allow a proton to be not just here, but also a little bit there, even where it has no energy to go, even where the classical laws say no. The tunneling effect means that for a brief moment, a proton can act as if the wall is thinner. And if the timing is right, if the overlap is just enough, the two particles can become one. And so they do. Not often, but often enough. It's a dance that never ends. A quiet fusion in the heart of every star. A miracle of persistence, repeating. In silence, you carry the evidence inside you, the calcium in your bones, the iron in your blood, the oxygen in your breath. These were forged in stars long gone, in suns that tunneled, fused, and finally exploded, scattering their elements into the dark. Your body is a map written in stardust and possibility. Even your heartbeat echoes the rhythm of particles finding each other through barriers too vast to explain, too small to see. You are the child of tunneling, born from crossings you never witnessed, carried by light that once slipped through the smallest crack in the rules. And now, as you lie still and warm, you feel connected to the stars, to the physics, to the chance that shapes everything. The light doesn't shout. It arrives gently. A photon touches your skin after a journey it never intended, but always made. This is how nature works. Not with commands, but with allowances. Not with absolutes, but with openings. You may feel small tonight, but the forces that hold you, that warmed you, that created the world around you, are born in impossibility made real. So let go of the idea that effort always means force, that progress must always push. Sometimes the most powerful transformation comes from slipping quietly through a wall, appearing where you're not supposed to be and changing everything. You breathe again, longer, deeper. You feel the warmth, not only of your blanket, but of a sun that should not burn as it does, and yet gently, persistently, does dot. And as the last light of thought flickers in your mind, you begin to wonder if the stars themselves are powered by quantum chance. What else in the universe rests upon a roll of gentle cosmic dice? You rest now in a deeper quiet. The warmth of the stars lingers in your breath, a calm reminder that even impossibility has its rhythm. But beneath that rhythm lies something stranger, something less certain, yet no less beautiful, at the smallest scales. The universe does not follow a script. It rolls dice, This is not a reckless throw, but a soft and deliberate letting go of control. A choice not to choose. Where will a particle appear? When will it shift, or scatter, or fade? You cannot say with certainty, only with probability. This is not chaos. It is something finer. It is chance braided into the fabric of reality. A kind of music made not of notes, but of likelihoods. You imagine now a particle in motion, an electron drifting through a cloud of possibilities. At every moment, it doesn't travel one path, but all paths, weighted by their odds. Some paths are more likely, some almost impossible. But even the least likely is not zero. Even the faintest possibility is invited, and from these layered maybes, a world emerges. The rules of quantum physics are not deterministic. They do not predict outcomes with certainty. They offer only the chances. You may measure a particle's location, and the wave function collapses. Suddenly, one of the many outcomes becomes real. But until then, everything hovers in potential. It's like tossing a coin, but one that contains every possible flip, every angle, every wobble, and only when you look does it land. This idea may feel strange at first. After all, we are taught to believe in facts, in solid cause and effect. But here, in the quantum realm, facts bloom from chances, not commands. And this is where the beauty lives. Because from randomness, from gentle rolls of nature's dice, order still arises, atoms still form, stars still shine. Life still blooms. The trick lies in the scale. A single roll of the dice tells you little, but trillions of rolls together paint a pattern so rich, so reliable, you might forget it began in chance. The universe is full of these quiet rollings, particles tunneling where they shouldn't, photons scattering in unpredictable paths, decay events happening with no trigger, only timing, and yet, on the larger scale, there is rhythm. The radioactive atom decays, not at a predictable second, but with a predictable average. Half will decay in 10 minutes, though no one can say which ones. It's not disorder. It's a soft trust in numbers. This is the kindness of quantum chance. It doesn't guarantee, but it gently balances. It lets the improbable happen, but makes sure the improbable doesn't become overwhelming. It keeps the world fluid, but not unrecognizable. You might think of it like rain. You cannot say where each drop will fall, but you can say when the clouds will burst. You can measure the storm, even as each droplet chooses its own path. This is the same with particles. Each one behaves like a question mark, but together they write an answer. Now your thoughts settle deeper. You picture your own body again, but this time you imagine the chance behind it. The molecules that formed you once drifted in clouds, born in stars, guided by fields and probabilities. Each reaction that led to your breath, your eyes, your heartbeat was a roll of nature's dice, but not a careless one. A roll within bounds, a chance that repeats again and again until a pattern forms. In this way, randomness is not the opposite of meaning. It is the canvas. Meaning is painted on. The same laws that allow particles to tunnel, to appear beyond barriers, also allow molecules to twist, to bind, to build. Chance is not a mistake. It is the foundation, and the more you zoom out, the more the randomness begins to blur into order. It's like static becoming music, like snowflakes forming from air, like stars emerging from gas and gravity. Even evolution, life's long journey, rests on chance. Mutations arise randomly, but the dance of survival shapes them. Selection creates purpose from unpredictability. So tonight, you don't need to fear the dice, because the universe does not roll them with indifference. It rolls them within rules, elegant, invisible, constant. Every time a particle tunnels, it's not by force, it's by odds. A rare event, but in the vastness of time and space, rare becomes routine. You let your mind drift now, carried by this idea that your world is the result of billions of quiet chances woven into something steady. You sleep not on solid ground, but on a sea of probabilities, held in place by numbers so vast they become stable. This is the paradox. The comfort that even though the bottom layer of the universe is soft, flickering, unpredictable, the top becomes firm, consistent, real. The sun still rises, your heart still beats, the rain still falls, because beneath every certainty there is a shimmer, a dance, a chance. You rest in that dance, not needing to control it, only to be part of it. Your breath slows. The world fades to softness. You might imagine now a quantum computer, a machine that uses superposition and entanglement to calculate not just one path, but many at once. These are not dreams. They are real, and they work not by abandoning chance, but by embracing it. And perhaps that's the message tonight. That randomness isn't the enemy of order, it is its origin. That to find the pattern, you must first allow for play. The universe doesn't roll dice to confuse you. It rolls dice to create you. And as your thoughts grow dim, your eyelids heavy, you wonder softly. If every outcome begins in chance, how many futures rest in the shimmer of a single possibility? You lie still, surrounded by silence, but somewhere in that silence is a hum. Not loud, not sharp, just the soft whisper of devices quietly working. In your room, in your pocket, in the very walls of your world, electricity pulses through wires, screens glow, circuits flicker to life, and behind all of it, behind every signal and every switch, is a phenomenon too small to see, but too important to ignore. Quantum tunneling. It is no longer just theory. It is practice. It is not just how stars burn. It is how your phone rings, how your computer thinks, how your world connects. You don't see it, but you live inside a web of tunnels. Tiny, invisible, silent, and each one a crossing that should be impossible. Each one a particle slipping through a barrier, not because it is strong, but because the barrier is not absolute. In classical terms, electrons should behave like marbles. They should stop when they hit a wall. But they don't, because they aren't marbles. They are waves, spread out, uncertain, capable of appearing beyond the edge. You imagine a field of semiconductors now, the building blocks of modern electronics, silicon, doped with other elements, to create tiny zones of possibility and resistance. When you press a key, tap a screen, speak into a device, you are not just moving plastic, you are asking electrons to tunnel in diodes, tunneling controls the direction of flow. In tunnel diodes, special, sensitive circuits, electrons cross barriers they shouldn't cross, creating unique curves in current, a kind of electrical whisper in flash memory where your photos, notes, and thoughts. Live tunneling writes the bits. It allows electrons to slip into an insulating layer where they stay or vanish, representing ones and zeros. Without tunneling, your voice would not be stored, your images would not be saved, your thoughts would not travel from one glowing screen to another It is humbling to realize that the world of technology, so sharp and sleek on the surface, rests on something as soft and strange as probability. You breathe with that thought now, letting your body sink into the mattress, your fingers relax, your thoughts slow. All around you are objects that rely on improbability. Your devices work not in spite of quantum strangeness, but because of it. Billions of transistors, the switches of the digital world, flick between states, each only nanometers wide. At that scale, walls are thin, distances are short, and tunneling becomes more likely. Designers must account for this. Engineers must plan for the fact that electrons will sometimes go where they're not expected to go, and sometimes they must go there, because that improbable motion is the very function of the device. You imagine a chip now etched with patterns finer than dust, thinner than a strand of hair. Each line is a path, each gap is a gate, and somewhere in that maze, a single electron finds itself on the wrong side of a barrier and tunnels. That motion, that vanishing and reappearing, becomes part of a signal, a message, a function. Tunneling, repeated millions of times, becomes a form of memory, of logic, of expression. It is strange to think that your voice, traveling across the world, relies on particles doing the unlikely, on physics taking a shortcut, but that's the beauty of it. What was once theoretical, once puzzling, is now essential. The math of Schrödinger's equation, the concepts of wave functions and probabilities, they are no longer confined to laboratories. They are in your home, your hand, your heartbeat. Quantum physics is not distant. It is personal, and tunneling is not rare. It is constant. You shift slightly, a nearby light glows softly. That glow, the result of a flow, that flow shaped by paths that aren't straight. That path made possible by the chance of tunneling. You may not feel the electron, you may not see the gap, but you benefit from its journey. The switch turns, the circuit closes, the device wakes, and somewhere inside, a barrier was crossed without force or sound. This is the whisper beneath electronics. A quiet permission, a subtle crossing, and it changes everything. Before tunneling was understood, devices were simpler, larger, slower. But now with each advance in miniaturization, each leap toward the atomic scale, tunneling becomes more relevant, more present, more necessary. In some devices, it must be limited, prevented from causing leakage or error or heat. In others, it is embraced, designed into the function like a secret passage written into the blueprint. And the future, it may belong even more to this quantum strangeness. Quantum tunneling is at the heart of scanning tunneling microscopes, tools that let us see individual atoms. By measuring the tunneling current between a tip and a surface, it is part of quantum computing, where bits are not just 0 or 1, but both, until they collapse into choice. It is part of physics, part of chemistry, part of your daily life. You breathe in, thinking of the device beside you. Its light dim now, its circuits resting, and inside it, trillions of electrons, each with a chance, each with a direction, each with a soft uncertainty. You rest knowing this. The world runs not on certainty, but on delicate permissions, not on hard rules, but on elegant allowances. Tunneling is not just about distance, it's about probability. It's about letting the unlikely happen over and over, until it becomes reality. Your breath steadies. You feel it now, that behind every beep, every glow, every stored word, there is a shimmer, a whisper. a crossing, and in that crossing, you begin to wonder, if quantum tunneling gives memory to machines, what quiet leaps might give memory to life itself. You rest now in stillness, not separate from the world, but threaded into it, not above nature, but moving within its quiet design. Your body breathes, your heart continues, and your cells hum with life's ancient rhythm. But have you ever asked, what moves within you? Not the visible motions, not the muscles or blood, but the tiniest exchanges, the smallest shifts that keep you alive without sound or signal. The answer lies in electrons, little bursts of negative charge. They dart, they shift, they pass from molecule to molecule, carrying energy where it's needed, sparking reactions in silence. In chemistry, electrons flow through bonds. In biology, they leap across spaces. And sometimes they tunnel. You imagine a single enzyme, a delicate machine folded from protein. Its shape is precise, designed not by a mind, but by evolution's patient brush. Within this enzyme, two sites wait. One donates an electron, one receives it. Between them is a gap, a space that classically is too wide, too far for the electron to jump, and yet the electron moves. It crosses, not by force, not by spark, but by a whisper. It tunnels. You may never feel it, but in the chemistry of your body, this leap happens again and again. In cellular respiration, in photosynthesis, in metabolism, electrons travel paths they should not be able to cross, and still they do. This is quantum tunneling, not in stars or circuits, but in you. It doesn't shout. It doesn't demand. It simply allows, because nature is efficient. It uses every tool, and in some places, when energy is tight, when gaps are small, it trusts tunneling to do the work. You lie. Still now, your own cells still glowing in the dark. And somewhere deep within them, electrons flicker between states. They find a destination not through direct contact, but through the shimmering haze of possibility. Even in the photosynthetic systems of plants, in the heart of a leaf catching sunlight, electrons are passed from molecule to molecule with such speed, such elegance, that tunneling is suspected to play a role. Energy doesn't wander. It chooses. It follows the most efficient path. And sometimes that path is through the improbable. The quantum world is not confined to labs and equations. It is inside every green blade of grass. It lives in your heartbeat, your breath, your every waking and sleeping moment. And perhaps the most miraculous part, these tunneling events don't disrupt life. They support it. They stabilize it. They are folded seamlessly into biology's plan. You pause here. Let your breath be soft. You imagine your body not just as bone and blood, but as a field of interactions, of fleeting exchanges. 100 trillion cells. Each one a world. Each one alive, because electrons move just far enough, just fast enough, to make reactions happen. And in some of those moments, the distance is too great, unless tunneling lends a hand. It's not the only mechanism. It doesn't happen everywhere. But when the architecture is right, when the molecules are aligned, when the energy is low and the gap is narrow, the electron tunnels. This leap doesn't burn fuel. It doesn't tear through space. It moves softly, quietly, like a thought, crossing a crowded room. And you are the result. You are the outcome of countless quiet crossings, not just in your own lifetime, but in the long memory of evolution. Because tunneling may have played a role in the earliest forms of life, in primitive enzymes, in the chemistry that predated cells, In the spark before memory, imagine it before DNA, before cells, before language, there were reactions, molecules exchanging energy, electrons choosing paths, and in the silence of that ancient ocean, perhaps one molecule passed its charge to another, not through contact, but through chance. A tunnel opened, the electron moved, and something changed, not by force, but by alignment, by possibility, and that change, repeated, selected, improved, became life, not by design, but by accumulation, by the soft power of time and tunneling. You breathe in, again, and this time, you feel it that you are not just alive, you are built from chance, built from events that happened because they were allowed to, because they were likely enough. You feel awe, not fear, because chance, in the hands of nature, doesn't mean fragility. It means flexibility. It means resilience. You are not rigid. You are adaptive. You are made from systems that learn to trust the improbable because it worked. And so you carry within you a soft kind of faith, not belief in outcome, but belief in opportunity. When electrons tunnel in enzymes, the reaction can be fast, more efficient than waiting for classical paths. It's like sending a message through a wall instead of around it. This helps cells act quickly, respond to changes, balance energy, and all of it from tiny, invisible crossings. You lie in the dark now, no longer separate from this dance. You are the dance, a composition of molecules, of charges, of fields and flows. You are not a machine. You are a poem written in chemistry, and some of its lines were tunneled. So when you feel tired, remember this: your body is not weak, it is wise. It moves energy not just with strength, but with subtlety. It trusts the soft shortcut, the unseen path, the leap that doesn't make sense until it's already made. And as your breath becomes even, as your thoughts grow light, you rest in this knowing that life does not always follow the expected route. It evolves, it adapts, it tunnels, and somewhere inside you, right now, an electron might be crossing a gap, quietly, gently, to help keep you alive. And you wonder, if life itself uses quantum tunnels, what other secrets lie in the crossings between certainty and chance? Tonight, you drift beside the edge of what is known, not far from sleep, not far from wonder. And beyond the stars, beyond your thoughts, there are people still awake, watching atoms, listening for the whisper of the impossible dot in quiet labs. Across the world, scientists coax particles into doing the improbable. They chill atoms to near absolute zero, where motion fades and silence reigns. They trap electrons in tiny wells. They shine lasers, build barriers just thin enough, then wait. They don't force nature. They ask, will you tunnel? Will you cross? And sometimes, with no warning and no noise, the answer appears. On the other side, measured, real, quantum tunneling was once a curiosity, a strange footnote in the equations. But now it is a tool, a doorway, a glimpse into what could be. You breathe deeply and imagine it, a world not just powered by tunneling, but guided by it, a future built from quantum crossings. It begins with control. Scientists can now prepare a single atom, place it in a potential well, a kind of energy valley, then place another well nearby. Separated by a thin barrier in classical physics, the atom should stay where it starts. But in quantum physics, there's a chance it will appear in the second well, not through climbing, not through energy, through tunneling. By repeating this, measuring it, modulating the environment. Researchers begin to shape the odds. They don't command the particle. They influence the probability. And that's enough. This leads to something more powerful: quantum control. The future of technology, at its smallest scale, may depend on this gentle influence, a coaxing of possibility. Quantum computers are one such dream. Unlike classical bits, which are either 0 or 1, quantum bits, or qubits, exist in superpositions, both 0 and 1, until measured. And how do they interact? Through entanglement, through tunneling, through the quiet rules of the quantum world. In some quantum computer designs, tunneling is part of the logic. It allows qubits to transition states in ways classical systems cannot. These transitions are not driven by heat or current, but by probability, by alignment, by careful design of the potential landscape. You lie back now as your mind floats across a circuit smaller than the width of a hair, etched with patterns meant to encourage a single particle to be here, then there. In this world, speed is not about pushing faster, it's about allowing faster decisions. A qubit can explore many paths at once, tunneling into answers instead of computing them one by one. It's like solving a maze, not by walking it, but by dissolving all walls at once and seeing where the exit lies. That is the power tunneling offers, not just motion, but possibility, and not just for machines. In biology, we've seen tunneling in enzymes. In physics, we've seen it in stars. Now, in quantum technology, we see it as a way forward into machines that learn, that sense, that calculate beyond our grasp. You may ask, what are scientists looking for when they build these experiments? They are looking for control. Not to make tunneling happen, that's nature's job, but to increase the chances, to guide the outcomes, to build new systems where tunneling isn't a surprise, but a feature. They create barriers of tunable height and width. They vary temperatures. They manipulate electric and magnetic fields. They design landscapes of possibility. Then let the particle choose. It's a strange kind of engineering, not of certainty, but of odds. You breathe slower. The idea comforts you. A future shaped not by brute force, but by invitations, by crafting environments that allow the improbable to become real. This is the tunnel to tomorrow. It won't be paved in metal and concrete. It will be carved from potential, built from the understanding that the universe always leaves a door ajar, however small, and some of those doors lead to breakthroughs already. Quantum tunneling is used in quantum annealers machines that find the lowest energy state in a sea of options, by letting particles tunnel into better solutions. This has implications for optimization problems, materials, science, drug discovery. Not guesses, but probabilities refined into clarity. You lie in the dark, and imagine a researcher waiting beside a detector, watching for a tiny signal. An atom has tunneled, an idea confirmed, a future shifted. It all begins at the edge of control, of measurement, of what is allowed. But even more, it begins at the edge of belief. For decades, tunneling was doubted, then studied, then harnessed. That is the arc of science. From wonder to question, from question to tool, from tool to truth. You let your thoughts stretch forward now. What comes next? Could tunneling help in sensors that detect magnetic fields with astonishing precision? Could it help model brain processes where electron flow is critical and distance too vast for classical jumps? Could it help us understand consciousness, memory, intuition, if those things rest, even in part, on quantum movement? The future. doesn't come all at once. It flickers first, like an electron beyond a wall. Then it lands. Then it stays. You breathe with that rhythm. You feel the openness of time. Tomorrow may be built not from what we know now, but from what we allow. And tunneling teaches us to allow, to expect the unexpected, to design for the unlikely, to create systems that trust particles to find their own paths. You rest easy now, because you live in a moment between two wells, between what is known and what is just beginning to shimmer on the other side. And the leap between them is not just possible, it is already happening. And so you wonder, if we can teach particles to tunnel, what else might we teach by offering the right kind of silence? The room is quiet now. The light, if any remains, is low and still. Your breath flows in slow, regular tides, and your body, no longer pulling against the day, rests without urgency. This is the threshold, the moment between waking and sleep, a place not fully here, but not entirely gone, a pause between certainty and surrender. You hover there gently, like a particle pressed against a barrier, its energy too low to cross, and yet not zero. There is a softness in this space, a shimmer, as if the rules of time and body begin to loosen, slipping through the seams of what you thought was solid. You begin to feel it, that your mind, like an electron, has a wave function of its own. It doesn't sit in one place. It spreads. It hums with likelihood. Your memories don't stack in rows. They drift. They echo. They rise and fall. And here, in this pre-sleep state, they stretch even further beyond the shape of the day, beyond the noise of names and places. You are here. And also, just a little bit, you are there, there in the image that comes to you, unbidden, a field, a river, a face, not fully remembered, but felt, there, in the sound not quite heard, a breeze, a voice, a line of music that never resolves, but lingers just enough to matter. Like a particle at the edge of a wall, your awareness begins to slip, not through effort, but through permission. This is tunneling, not in science, but in self, a kind of presence that doesn't need to pass through the barrier, only to extend into it. You don't need to know what's on the other side. You only need to feel that something waits, and that feeling is enough to move you forward. In the quantum world, a particle never arrives with certainty. It is found, but not predicted. It appears, but never by decree. The rules are soft here. Just like now, as your mind prepares to sleep, you may think you drift into sleep as one thing, one person, in one moment. But the truth is more blurred. You fall asleep in pieces, not suddenly, but gradually. Some parts of your brain quiet first, the ones that track time, that weigh tasks, that speak. Other parts hum longer, the ones that imagine, that wander, that dream, and before you know it, you are both thinking and dreaming, both present and fading. This is not failure. This is tunneling. Your thoughts move beyond the barrier of intention into something less structured, more free. And in that freedom, new things are possible. Memories rearrange, ideas spark, fears soften, emotions reweave themselves. This is not a pause, it is a process. And it's powered, in part, by your willingness to let go, to hover at the edge, and allow yourself to slip through. You may wonder if tunneling in atoms enables stars, enables life, enables computation. What does tunneling in thought allow? Perhaps it's this, that insight doesn't always come through step-by-step reasoning. Sometimes it comes from the blur, from the moment just before waking, from the dream you only half remember, from the space where logic rests and something more fluid begins. You drift through that space now. The world does not vanish when you sleep. It changes form. You carry with you a kind of awareness, not sharp, not verbal, but deep. The part of you that knows how to breathe without thinking, that heals without command, that dreams without blueprint. This part of you is ancient, and tonight it slides forward, through the wall. Through the veil, your conscious mind quiets, but something remains, curious, gentle, unfolding. You remember now what tunneling truly is, not escape, not force, not even motion. It is presence in the improbable. It is becoming real in a place you were told you could not be. It is existing despite. You felt this in waking life, too. Moments where the odds were low, but the outcome arrived. Moments where you shouldn't have found a path, but did. Where a door opened, not because you pushed, but because you waited. That is tunneling. It lives in nature. It lives in machines. It lives in you. Tonight, you join it, not as a concept, but as a rhythm. Your thoughts soften now. Their edges no longer distinct. They are waveforms, overlapping, rising and falling. They do not resolve into facts. They simply are, and that is enough. Your breath is slow, your limbs heavy. The world no longer arrives in words, but in pulses. And as you drift, you understand something very old, that to fall asleep is not to fall away. It is to enter another possibility, one with different rules, one where time loops and images flicker, and every sound is a suggestion. You are not gone, you are elsewhere. Particles do not vanish when they tunnel, they appear in a new place, a new state, and so do you. Your bed becomes a capsule, cradling this transformation. The ceiling above you fades. The walls stretch outward. Your awareness, once small and narrow, now curves gently into something rounder, a space with no need for clocks, no need for plans, only rhythm, only being. You no longer ask, what comes next? You only ask, where am I now? And even that question fades, because the answer isn't a point. It's a cloud, a hum, a wave of soft presence. Particles don't sleep, but you do, and yet your sleep is not a shutting down. It is a tunneling inward, through layers of self, through memories not yet formed, through meanings not yet found. And, on the other side, a new day, a new arrangement, a new you. You may not remember the crossing, but you will feel the effect, the same way an atom doesn't remember its tunneling, but it arrives, and the world changes. As you slip fully into this deeper sleep, your mind quiets completely. The observer within you steps back, and the wave of you spreads. You are no longer just here. You are across the wall, in another place, another possibility. There are no edges here, only soft currents, only rhythms, and somewhere a final thought lingers, gentle, unresolved, like a question you don't need to answer. If the rules can bend even for the smallest particles, then perhaps the most important journeys begin not with direction, but with surrender. You've traveled through the quantum world, where walls shimmer, where chance leads to certainty, and where even silence holds a pattern. May your dreams tunnel gently onward,